Okay, fine. So we're doing line ratio. So in 5 towns, I got the impression that they learned a different way to do this. So I'm not sure, but mostly they were okay with doing it this way. Second. And Rick and Sarah, you saw how we did it at the tutor night. So really, it's just for Sam. So kind of similar to what you were saying. Basically, I tell them to make a chart on their page, X and Y.
Yeah.
I tell them to do X2 minus X1, that gives you a value of 10. Y2 minus Y1, that gives you a value of 5. Then, you add up this number, you get 5. That's going to be the number that we're dividing by. So we divide by 5. Divide by 5. And what we get is, we get 2 and 1. Then we go to the original term, -6, comma, -5, and we add that value the number of times of the first number. So we add it twice.
Gotcha.
So you do it once, you get -4, comma, -4. Then you add it one more time, and you get -2, comma, -3. That's the answer.
Right.
Yeah, it takes them a lot of work to do. You just got to do, do 4 in a row. In 5 towns, the curriculum's really quick, so I don't know if you have time to do that, but I don't think we need to go through these. I think everyone knows how to do them. Yeah.
Mm-hmm.
Try them beforehand. I don't think there's typos that I know of, but maybe there are. Okay, the equation of the lines ones. So fine, number 7 is just a warm-up. 2 right lines that intersect there to form right angles as perpendicular lines. What is the slope of a line that's parallel to this? Step 1, get into y equals, right? Equals, okay, so that should be basic. Now, this is actually important. So you subtract 2, so you get 4x minus 2 equals 4y. Then you divide by 4. Now, most students, when they do it, will just put the whole thing over 4. Which I think makes it confusing, because then what's the slope and what's the intercept? I tell them, like, distribute the dividing right off the bat. So divide by 4, you get x minus 1/2 equals y, and then the slope is going to be 1. Okay, so that should be that. Okay. Which equation represents the line that's parallel to the line 2y minus 10 equals x? Which equation represents the line that's parallel to the equation? Okay, so again, y equals, fine, basic, warm
up. Would you
up.
just have them graph it and...
No.
You want it all algebraic, okay.
Yeah, you have to get into y equals anyway. Then it's just
so you
picking
might as well
out
just
the
look
negative
at it.
reciprocals,
Gotcha.
yeah. Alright, so all this is just warm up
What is 19?
line stuff. Number 19.
Was it 4?
This pair are, so any,
I know what
yes.
collinear
Okay,
is.
so collinear means the same line.
Same line. Okay.
Same line. They're like on the same line. Intersecting is any 2 lines that are not parallel. Perpendicular is only perpendicular lines. And parallel is parallel. Good. I don't know if I would get through all these questions. If it seemed like they were doing okay.
So what was the answer to this one?
So I think the answer is what
4.
you said. Yeah, 4 intersecting but not parallel.
So if the equations were identical to each other, then it would be collinear.
Correct. This is not a really
if
good
it
question,
had...
so I wouldn't
Oh,
stress
no?
on that.
Okay, fine.
I've never seen that. Okay. Finding the equation of a line. So very simple system that I like to explain anytime you want to find the equation of a line. You have 2 steps. Step 1, you need the equation of a line is y equals mx plus b. Now step 1 is always going to be to find m, and step 2 is always going to be to find b. Okay, now how do you find m? There's a couple of different ways. If they give you 2 points, you're going to find m by using the slope formula. The slope formula is y2 minus y1 over x2 minus x1. Right, so you would go here, you do the slope formula. Y2 minus 4 minus 4 is minus 8. Minus 2 minus 6 is also minus 8. Yeah, so the slope is 1. And then you would, now how do you find the b? You would always find the b in a similar way. You plug into the equation y equals mx plus b. We now know that the m is 1. Where do we get the point? We use a point on the line. So let's use the positive points. Why not? 4 equals 1 times 6 plus b. You minus, you get b equals -2. Final answer then would be y equals 1x minus 2. Obviously, you could also say x, but that one is just for the student's benefit. They know that it'd be like 1. Good? Very simple. Okay, so that's one when they gave us 2 points. How else could they ask this question? They'll give us a different line and they'll tell us our line is parallel to this line. And then they'll always give you a point on your line. So this line slope is 4. We have a slope. Now we just need to plug it. We need to find b. So we have the equation y equals mx plus b. We plug in y is 0 times 4 6 times 6 plus b minus 24. b equals minus 24. Final answer, y equals 4x minus 24. Cool. Click. Good?
Yep.
Where did it go? Oh, it's back. Nice. Okay. So that is that. All right. We don't need to do a zillion, but that's the basic idea. Always the same structure, always the same form. Make sure they know how to do it. On number 12, they tell you that it's the perpendicular bisector. So that's a tough question. So what does that tell me? That tells me, first of all, step 1 is at the perpendicular line. Okay, so I find the slope of this one here. -7 minus 5 is -12. 5 minus 11 is going to be 6. Slope of -2. So my slope is positive 1/2. Then these are all in a mess. So you got to clean every single one of these up, which is a complete nightmare. But that's what I would probably do. And I would imagine I'm going to be able to eliminate choices based on doing that. So let's try to do it. Let's work them one at a time. So give me a second. I'll clear some space.
So quick, the slope, isn't the slope just -7?
-7 minus 5 got me minus 12.
And then
5
minus 11. 16.
Oh, okay, good. So I made a mistake. 16. So what did you get? -2
Negative-
over 3?
-3/4.
-3/4. So
Which
our slope is going to be
yeah, our slope's going to be
4 over 3. Oh, fine.
So then it's going to be.
Also.
Oh, okay, so that's very helpful. Okay, so
Yeah.
now let's look at them. So off the bat, you could kind of see just from step 1, right, that you could eliminate choice 2 and choice 4. So that at least is something. To get past that, you have to actually be pretty good at this. To get past that, what you're going to need to do is realize that the bisector hits the midpoint of these 2 lines. So you would have to do midpoint formula. Midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. You're just taking the average of each point. So we could do it. -7 plus 5 so x is going to be -11 plus 5 is 6, -6, comma, right, -6 over 2, and -7 and 2 is 2, is -2 over 2. So you get the point -3, comma, -1. That point's a point on the line. Now you can either plug this point in manually. That's actually easier to do. Number 1 works, right? -3, 0, -1, 0. That's a hard question, though. I wouldn't do. The order should probably be a little bit different. That one should be last. But that's because they need the midpoint formula. I would introduce the midpoint formula. You know what? This one I would probably do with them. There's like some questions that you say, okay, try this, and there's some you just show them so they feel like it's cool. They saw it, but you wouldn't like let them do it on their own and feel like shit. 14. What is the slope from A to BC? What is the slope of the altitude drawn from A to BC? So again, the altitude is going to be perpendicular, not a bisector though. So it's just a perpendicular slope. I'm struggling to draw it, but it's just a perpendicular slope to BC. You take the thing of BC. This one is easier. The order's a little bit gassy here. I didn't reorder this, but yeah, it's not too hard. Rick, you good?
Yeah, it's just -5 over 3.
Okay, good. Dilations of lines. I made this lesson 1 really flashy. This should be fun to teach. Like, this is all very easy stuff to teach. And like they should get excited by you teaching it. So like dilation of lines is a weird thing.
I never heard of this.
Yeah, so basically you're taking a line. I don't know if drawing this is going to help, so just humor me for a second because I saw this, it once explained like this, and then I didn't really understand it all. But you have this line, right? They're telling you to take a point, right, on the line, a point that the dilation is centered around. Let's say the point's over here, okay? say the point's over here. And then they're saying to dilate the line centered around this point by a scale factor, right?
What does dilate mean?
So dilation in general, you have a triangle, you dilate it, you multiply each side length by that distance. So dilate means multiply. So here what this really is doing is you would see you don't have to ever do this, but you would see the difference between the point and the line. And then you would multiply the scale factor by that difference.
What's the scale factor?
They give you a scale factor. It's
What
just
does that mean?
the number that you're multiplying, basically. And you would end up with a line that's a parallel line that's that distance times the scale factor away from the initial point. Okay, something like that. Now, if the point that you're dilating, on is on the line, then the distance between the point and the line is 0. So even when you multiply it by a scale factor, the line's going to remain unchanged. The distance between the point and the line. So let's say the distance from here to the line is 6. Then the scale factor is 3, so it would be 18 or something. And you understand?
I'm saying why if the point's on the line is it 0?
Because the distance
if this
between
point is on that line.
Yeah.
Gotcha.
Something like that, okay? Now, that's all gibberish. You don't have to understand any of that really to do these, okay? But that's just like, as a teacher, you may want to understand it. It's a basic thing. One is the point centered around, the point that it's centered around, located on the line. If it is, the line doesn't change. If it isn't, it's usually centered around the origin. If it isn't, it's always centered around the origin. And then you just multiply the intercept by the scale factor. So let's just do an example. You have this thing here. They give you a scale factor, as we said, and a point. You plug the point in, so you get 8 equals 3 times 3, right? 3 times 3 minus 1. Is the point on the line?
Yes.
8 equals 9 minus 1. 8 equals 8. Yes, the point is on the line. Good, I plug the point in.
To see if it's on the line.
See if it's on the line. If it's on the line doesn't change. The answer right off the bat is 4, okay? If this point happened to not be on the line, then you would just do 2 times negative 1, and you would get negative 2, choice 3, okay? Let's look at another example. This one here. So they tell you scale factor of 3 over 2 and centered at the origin. Meanwhile, I'm pretty sure if the point that it's centered on, if they give you that point,
it is on the line?
It's going to be on the line if they're asking you to find the slope, yeah.
Because they tell you the origin, it's usually not.
I know, the origin can or cannot be on the line, right? But usually the origin's not going to be, because you can't, the rule multiplied by the scale factor only applies if it's centered at the origin. Because you're multiplying, just to go back to the graph, you're multiplying the intercept by the scale factor. The reason is because the intercept is the distance between the origin, and that only applies.
So they're never going to do just a
they're never going to give you a point, right, and then you have to do it. You can't do that, yeah. Exactly, so it's pretty basic. So centered at the origin, you plug the origin in, 0, 0, you get 0 equals negative 4. Does that work? No, it doesn't. The point's not on the line. So you take 3 over 2 and multiply it by the intercept. You get negative 12 over 2 and negative 6. So the answer is 2x minus 6. Right off the bat, anyway, 3 and 4, the slope never changes.
Right.
So this is a flashy, I don't know if their teachers teach it well, and it's so easy. So right over here is scale factor of 4 with respect to the origin. 0, 0 equals 1. No, point's not on the line, so it's y equals 1 minus 2x. You're going to multiply the 1 by 4, so it's going to be negative 2x and 4. That's simple. Easy, okay? I don't think we even need to do more of these, but with the students,
does it get harder?
they're all this. No, it doesn't get harder. So I'm teaching, I made it that lesson 1 should be the most exciting lesson. Yes, tell me.
You multiply the
intercept.
The intercept, thank you.
Slope never changes. Good picture how it would look on the graph, okay? So, let's look at
you
number
never have
10.
to find the distance?
No. The wording could get tough. Like a line passes through the points whose coordinates are, oh shit. We're missing a thing. So you can't do this question. Okay. Let's say this one. A centered at the origin, which linear could be its image? This one's really bitchy. You gotta get them all into y equals or be able to see. So this one's slope is negative 2 over 3, right? It doesn't even give you the scale factor. It just says centered at the origin. So basically, centered at the origin 0, 0, it's not on the line, right? But the slope of the initial is negative 2 over 3. We know the slope of ours needs to be negative 2 over 3. One would fit that bill. This one wouldn't. It would be positive 2 over 3. I'm doing it in my head. If you need to get it into y equals, you could do that. Minus 3 divided by 2. That's negative 2 over... That's negative 3 over 2. Now this one would get you negative 3 over 2 minus 3x. and this one plus 2y divided, you get positive 3 over 2. So the only one that would work is 1. It's the only one that has the same slope. Rick, you good? Could you see the screen? Yeah?
Did they ever ask you to find the scale factor?
Never ask you, no. Really, really easy. This is an easy topic. I don't know why they ask it. Okay, so that's lesson 1, by the way. That's going to take, and that's a jam-packed lesson 1. That should take an hour and 5 towns. In Brooklyn, it'll be even skimpier than that, okay? The next topic is similar triangles. I think similar triangles is one of the most important topics that comes up on the region by a good amount. It's asked very, very frequently. So
Am I teaching until like the bell rings or whatnot, or am I just?
It's not a bell. Yeah, you're
Whatever.
teaching for a full hour. Yeah.
No, what I'm saying, am I trying to get as much as I can in the hour, or am I? Like,
Yeah, your lesson should be packed. I don't anticipate you finishing early, but never let them out early anyway.
Okay, just keep going.
Yeah, I mean, finish the lessons, but
Your
go
lessons are
back
not
and do some of the
skimpy.
hard stuff. Your lessons are really packed. Like, you're not going to get through unless you have a bunch of geniuses, in which case you could do all the hard questions and whatever. Okay, similar triangles. So I put this example here as a very basic example. Now with similar triangles, the rule is you have 2 triangles who are similar. Like, let's draw a clear example that we would understand how it would work. We have this triangle who's similar to this mini guy. This guy's a 3, 4, 5 triangle. This guy's a 6 something, 10 triangle. What is he? He's a 6, 8, 10 triangle. The way that you could solve it is by setting up proportions. Now, there's so many proportions that work, okay? Like, just to, let's make a list of all the proportions that work. 3 over 4 equals 6 over x. Works, right? Okay, 1. 3 over 6 equals 4 over x. Works. It's 5 over, you know what I'm saying? 5 over 10, 10 over 5, 5 over 3, 5 over x, whatever. There's so you can't tell the student which one to do. You could just show them which one doesn't work. So if someone, go around always and ask them what they did. And if someone does one that doesn't work, make everyone say why it didn't work. So let's say someone did something like this. 3 over 4 equals x over 6. You matched this top line was triangle 1. Because this is triangle 2. Then this guy's got to be again 1. You understand? X is now triangle 2. Okay, because this is x. Alright, fine. So that's that. So now I gave a basic example here for them to work through. So they could set up a basic thing. It's very small, yeah. But they could set up like 6 over k equals 24 over 12. And they would quickly realize that k equals 3. Okay, and you'd go around. This is a warm-up. Most of them know what to do. Like, you don't need to explain the ratio idea. They've done it. You just got to make sure that they can do it in the most basic way. Now, the Regents focus primarily on 2 types of similar triangles. Similar triangle number 1 and similar triangle number 2. This is similar triangle number 1 and this is number 2. Now, in similar triangle number 1, this angle is equal to this angle. This angle is obviously equal to itself. And this angle is equal to this angle. So because of that, if the sides go that this side is equal to this side, you understand?
Yeah.
This side is equal to that side when you set up the proportions. And in this other similar triangle, you have the vertical angle, obviously, and then you have the alternate interior angles, the z angle. So it's that and that one. So it's this side with this side.
So it's A and B.
And also, and also this side.
And they
with
give
this
like
side.
this always AC is parallel to DB.
Yeah, I mean, either they'll ask you to prove that AC is parallel to DB, in which case you would check to
an
see if the
alternate whatever,
triangles
yeah.
were similar, or they would give you that and they tell you they're parallel and you need to realize it's a similar triangle situation. But when you see either of these pictures on the Regents, similar triangle question, okay? That's the hint, okay? So let's do number 11. Now, number 11, everyone take a second and do number 11 on your own, actually. So a couple of things on this one though that could be tricky. Ken,
Oh, yeah.
I got it to undo. It just like disappears the toolbar, and I need the toolbar. The pen. Right there. I don't think they need to show that anymore on my launch. Okay. So here, there's a couple of ways that they would set it up. One option that they would do is 9 over 9.2, and this is the mistaken option, equals 5 over x. I don't think that works. It may work, but it's not the way that I would explain it to you.
It actually does.
It does work, but
because
it's
they're
not the way that.
proportions,
Right.
So, even when
So
you
they
cut it.
can do that. So if they do that, that's okay. But I would like them to be able to see that it's 9 over 14 that
Right.
equals 9.2 over 9.2 plus x. That's like the ideal way for them to see it.
Not just
if you're
like
calling this x.
we're looking for AC, so it's just
Oh, good. So an even better way would be,
X.
fine. I thought they were asking for BC. You're right. You're asking for AC. So it would just be plus x.
Yeah.
And then you could say, fine, great. Okay, now 17 is another example. They just ask you which are justified by the similarity. So if they said AD is 3 and AB is 6, then AE 4 and 12. We could eyeball that. 3 to 6 is double, 4 to 12 is not double. But really, these are so simple. You just do this on a calculator. 3 over 6 equals 4 over 12. I don't think they ever change the order. I've never seen the order be different than this. 5 over 8 equals 7 over 10. 3 over 9 equals 5 over 10. All these reject, right? And then 2 over 6 equals 5 over 15. So it's really easy. Okay? Compared to trig, this stuff, I don't know. Trig set the bar really. Okay, now this one is a little bit tougher. It's a similar idea though. Which one's justify similarity by side, angle, side? So two of them are going to work. Watch, 6 over 8 equals 9 over 12. Does that work?
Mm-hmm.
That does work?
yeah, they're both
Divided by
3 over
3.
4.
Yeah, so that works, okay. 8 over 10 and 6 over 8 doesn't work. 36 over 64 doesn't work. 15 over 20 does work. Okay, now two of them work, but side, angle, side. Oh, so side, angle, side, by the way, proves similarity also. They were asking me that. Side, angle, side, it's going to have to be angle A. So it's choice 1. And this is the kind of stupid question that rewards the lazy student that didn't do all of them. I think the order of the question should be reversed. But
Because
yeah,
the angle needs to be between two sides.
it's side, angle, side. Yeah.
Right.
Okay, good.
Yeah.
Next one, I think. Okay, so this one, it doesn't tell you that they're parallel. It says explain why they are parallel. So again, the core of this is that these are parallel lines. If they're not, then it doesn't work. So explain why they are. So you would do again the proportion. You could even do fine. So it looks like you could just do it. So maybe we shouldn't even be fighting against it. 3.75 over 5 equals 4.5 over 6. Let's just do it this
Is
way.
that
Then.
supposed to work?
If it works, then let's just do it that way. Check. Yeah, it's
Why?
supposed to work.
Oh, it is? Is that like...
Because, what do you mean? Oh, doing it piece by piece instead of the whole thing?
Yeah.
Yeah, I guess because if
There's an essay.
they're in proportion, then the pieces are in proportion too. I don't know if it works. It works. You know what I'm saying?
It totally works.
It works. So
Yeah.
that's it. Let's just do it that way then. So this works, and then because it works, so you would say that triangle ABE is similar to triangle ECD, and that because of that, line A is parallel to CD.
Because they're parallel, the distance between them is always going to be the same. So that's why you can use the smaller pieces.
Okay, fine. Whatever. The idea that they're parallel is what makes these angles equal and what causes those sides to be in proportion. So that's why the parallel is important. Okay, cute. Number this one here. I don't know how did this get cut off? It's annoying. I thought I did it good. It doesn't look cut off on Word, and then it is cut off. No,
Which one? 12?
saying whatever. Okay,
That is cut off. No, it's not.
that N. What is that?
What
Didn't
is the
even
N
print.
doing there?
I don't know what it's doing there. I don't know. All right, fine. Okay, this one here, is this the gassy one? No, it's a good one. Okay, so this is basic. Next one, same deal. Let's look at this 27 with the lake. So here you're telling me I could do the pieces also, Sam? No, here if I did the pieces, I wouldn't work. No, it wouldn't work. It wouldn't work. If I did the
CE
pieces.
to EA
No,
and BD to DA would work.
CD,
CE
CE,
over EA is equal to BD over DA.
CE over EA. Oh. So you're saying I could do... No, that's not true. It's not true. If I did 230 over 85
That would
equals 120 over X.
I mean, you don't have that.
It's not
No,
right.
it's not 120. Right. I'm saying DA and BD would work.
But I'm not looking for that.
Right.
Right.
But you could,
But
whatever.
they didn't give me.
Yeah.
Yeah, I'm saying, so that's the reason why
It's
not.
the two
In this
side
case, you would
ones.
need to do 230 over 120 or something like this equals the whole thing. So it's 315 over X. Right? So that's why. Yeah, what'd you do, Tommy?
I did the same thing.
Yeah,
I
that's
just
what I'm saying. So
flipped
students are always gonna be like that. I did it, so yes, that's why you shouldn't even tell them like what I just said. That's not really good to do. It's gonna confuse you because you didn't need to do it the way I did it. Okay, fine. Then this one, which one's not always true? So we know 1 and 2 are definitely similar triangle situations, and then this one gives you 2 angles are equal, so it's just not true for 4. They only give you 1 angle in AD, and whatever. Okay.
Oh, which one is it?
So the answer is choice 4, the one that's not always true. Okay, now we're on the next one. They say they give you parallel. Do they give you parallel? They don't, but I guess assume parallel, or they probably give you parallel somewhere. So what do they want? They want the length of CB. Oh, I guess by giving you the angle 115, that's the way of giving you
Right,
parallel.
65, yes,
Now,
alternate
but-
interior.
Bottom line is this is similar. If they're asking you to find it, it was obviously a similar triangle. You know what I'm saying? So like X. Oh, here's the X. Okay, so for here, this one they could be a little confused. You could do, the 6 and 15 are the ones that have the relationship and the 4 and the X. So whatever proportion you did with that, and then so now here, CE with DE. Okay, that's good. EB. What's wrong with that? CE with ED. Okay. EB, what's wrong with that? They went to triangle number 2 now with that second one, right? They went triangle 1, triangle 2, triangle 2, triangle 1. So 1 doesn't work. AEBE works. ACBD works. That's the answer. Right? Everyone saw that? AEBE, ACBD. Okay, that works. Everyone sees it? ACAE. BE, you can't go to BE. BE goes with AE. You're the one with AC now. You see what I'm doing? So fine. That's actually a cute question. This one's in a circle, so there's ways that you would know that this is a similar triangle because a tangent and a diameter form right angles. We didn't get the circles yet, though. Bottom line, it's that same picture. If they're asking you to find it, then you know it's going to be a similar triangle situation. So it's 4 over 10 or something like this equals 5 over x. This gives you BC. And then easy, 4x equals 50. Divided by 4, x equals 8. This geometry, come on, you gotta love it. This geometry is so easy. I don't know, I have to trig. I love this. It's nothing better than this. Okay. So now, here they give you AB equals 9, BC equals 15, D equals 6, and EF equals 10. Which statement is true? So you check 6 to 9, 10 to 15, that is true. So the triangles are similar. Is that an answer? Yeah. So that's the answer. Okay, fine.
And
Yeah. Okay, this one's basic. I don't think we need to go over it, but you guys should all using information which cannot be proven similar. So again, they're in proportion 3, 9, 4, 12. So this is similar. This they give you angle is similar. This they give you angle and are the sides in proportion? No. So this is not 2 to 16 is times 8, 8, right? So this is the answer. And this one they give you side, angle, side.
so
which
side,
is
angle, side,
side, angle,
proves
side
similar,
proves
and
similar.
side, and
But
angle,
doesn't
angle,
side,
angle.
angle, side prove congruent?
The answer's 3.
Doesn't what?
Right.
Yeah.
Yeah.
So if it proves congruent, isn't it pshita that they're similar?
Yeah, but I guess.
So I don't really get that. The kids were telling me that. Isn't one of them side, angle, side similar? And I was like, yeah, that's congruent. So yeah, obviously similar. But I guess there's something
But it's
uniquely...
confusing because if they're the same, then they're not really like they technically are similar. Their sides are in proportion because they're equal, but it's not
Yeah, but I'm
that
saying
same.
they only use side, angle, side. Why not do side, side, side? Similar by side, side, side.
That's how I used to learn it. That side are similar.
Okay, fine. Okay. The next one is interesting. They tell you that they're similar, and then they tell you AC is 12, DC is 7, DE is 5, and then so obviously you could find, and which angles do they give you? Did they give you any of the angles? No, but they tell you triangle ABC and DC. Whenever they tell you this, what that means is A goes with D, B goes with E, and this one goes with itself. That angle's equal to that one. So it would be 7 and 12 and 5 in this. Now,
that always works.
Yeah. Now,
That's great.
easy. Yeah, it's great. Now, an easier thing to do anyway would just be they tell you that the perimeter of ABC is 30, so you
Yeah.
could just say 12 is to 30 as 7 is to x, and then you get the perimeter. Okay. This one here is a nightmare, so let's just do it together. I think the key is to redraw OTU, okay? So let's just figure out first what the deal is, which one goes with which. They give you that angle C is angle OTU, is this angle, you understand? So I would move this triangle out and make it look like this triangle. So I would copy a replica where this T is down here, and then that O would be up there. Would the O be up there? Sorry. Yeah, and then this would be U. I actually reflected it over that. Like, you see what I did? I took this guy out and I reflected him over this. So now that you have it drawn out like this, it'll be a cakewalk. But if you tried to do it in there, I promise it would be so hard. Yeah, everyone saw what I did?
Yeah.
Okay, so now
S.
TU is 4, so I would write it down here. I mean, I would also write it up here. I put it on both diagrams. OU is 5. Yeah, you're going to have to label both diagrams. OU is 5. And ST, we're trying to find the length of ST. Okay, so I guess you'd probably find the whole thing.
Yeah,
and then
you subtract.
yeah. So now, but what do we even have on this big triangle? We don't have anything. So here we have.
You have 12.
Oh, they gave me. Where did they give me 12?
CO is 7.
CO is
So it's
7
just-
and OU
Oh,
is 5.
CO7.
Or you could do
So now you would say 12 is to 4, or something like that. 12 is to 4 as 4 plus x, or yeah, 4 plus x is probably the better. 4 plus x is to 5. And then it's 60 equals 16 plus 4x minus 16. 44 equals 4x divided by 4. X equals 11. Sorry, give me a second. Okay, is that good? Everyone could try the flagpole one now. The next one. Rick, do you need to go?
What time is it?
10:40.
I have to go home and get dressed.
So I'm saying you need to go.
Yeah,
Yeah, okay,
We're
fine.
pretty
So we're
much
just
done.
doing
I know
yeah.
this.
So we're just finishing this
Okay.
lesson. All right. Bye, Rick.
Thank you.
No problem. All right, I think are we done? Does everyone want to try the flagpole one?
What's
Try
the
the flagpole
flagpole?
one. Just try number 31. It's up there. I'm gonna make it bigger for you.
Can you guys print this one out for me? So I can have it.
I'm gonna have a copy of the book. I'll bring it tomorrow night. You'll get it.
Hi, Mom. Should I come home and should I change or should I go home and change first?
Ricky, do you want a shirt or something?
No, I know. I need your dress for the day. I'm on my makeup for the day. Okay. Thank you.
Bye.
How do I draw this? I'm never good at these protocols.
Yeah, and
Yeah.
I'm not good.
okay, so if someone has a hard time with drawing, then yeah, okay. So a flagpole casts a shadow 16 meters long. So let's say the sun's up there on a nice sunny day, and he makes a shadow that is 16 meters long. I shouldn't have done that. Okay, 16 meters long. Okay. Tim stands a distance of 12.5 from the base of the flagpole. So let's say you got this guy Timmy here. He's 12.45 away. and Tim shadows meets the end of the flagpole shadow. So this is 12.45, and then this is 0.555, 3.55, right? Because the total was 16. Shoot. Okay, now you have a triangle, similar triangle situation with Timmy's head. So they want to know,
1.65.
right? Timmy, they said it stands 1.65 meters tall. Right, so now 1.65 is the height of this triangle, triangle 1. So 1.65 is to 3.55 as x is to 16.
Gotcha. It's hard that he's
In there.
like I was putting him on the left
On the
side,
left
and then
side.
I was like, this is not a triangle.
Yeah, it's hard.
Okay, I see that now.
Sometimes they hit them in circles, fine. This one's another example where when we get to the circle lesson, we'll realize that both of these are 90-degree angles or something close to them because they intersect the same arc. So if they intersect the same arc, they're equal to half the arc measure. So their angles are congruent. And then you have these are similar, so they're similar triangle situations.
Come again.
We'll get to that with circles. We're not doing it right now. But all I'm saying is you have these two triangles.
Yeah.
Most likely it's a similar triangle situation. What else are they asking you about?
The
CG
angles
and,
are vertical.
so CG, so right, but which angles are the ones? So I wouldn't even do this question, but which angles are the ones? It's this angle and this angle.
Right.
And then it's this angle and this angle. The reason that it's that is because the rule, let's say we'll get to it in circles, but you have an
EV,
arc
EV.
here. Let's say this arc makes up 70 degrees of the circle.
Then that 70%.
So then this angle would be called 35 degrees.
Because
So if two angles happen to open up to the same arc, their measure is going to be equal. So that's the situation here. They're both opening up to this arc. Whatever the measure of it is, the degree measure, then that's going to be half of it.
And the
So
same thing
those
with
two sides.
ED.
So now, and same thing with ED, exactly.
So
So now,
angle.
right. So now, you just know that CG, okay, is congruent to FG. No, not congruent, right? Okay. Angle CEG congruent to angle FDG. Yes, true. CEG, FDG. Okay. CE is to EG. Okay. As FD, okay, is to DG. EG. That one works also. Oh, so this one's the one that's not always true. Sorry, it's a not always true. And then the triangle is similar. Oh, okay. So this one just stands out anyway, right? You could kind of get the feel. Okay, these would all be true in a similar triangle situation. Obviously, it's a similar triangle. Okay, so that's it. So we did lesson 1. We're gonna have to do.